So all we're doing in 4.2 is talking about graphical features of rational functions because we're going to eventually be graphing them. And here are the big key things. So a vertical asymptote is an asymptote that's going vertically, obviously. So as x is approaching some number c, so I'm going to show you in like this picture. If I highlight right here, this is a vertical asymptote. The y's will be approaching either infinity or negative infinity. So notice how the arrow over here is going up, approaching x equals 1, and then this one's going down to negative infinity. Okay. Sometimes they'll both be approaching the same direction. So this one right here would also have a vertical asymptote at 1 because those arrows are approaching that x value. Horizontal asymptote is the same idea but going horizontally. So right here on this one, there is a horizontal asymptote at -1. So that's a y value we're approaching, and this time the x's will be approaching positive and negative infinity. Now, not everything is going to have a horizontal asymptote on these. Sometimes you'll have what's called an oblique, and that's what the second example is. Oblique asymptote is a slanted line, so something in the form y equals mx plus b that we're approaching, but the x's would be once again approaching negative and positive infinity. Last but not least, we've got holes. Holes are the point of discontinuity, so that's this right here. You'll know it because it's literally just an open circle somewhere. So it's connected to everything, but the graph is connected on either side, but there's a hole in that one specific spot. So your homework tonight is literally you're going to look at graphs and you're going to name all of these. So let me give you an example. And you also have to name domain, range, your x and y intercepts, and vertical, and then all the asymptotes and stuff. So I'm going to go a little out of order. We're going to start with our vertical asymptotes and horizontal asymptotes. I think it'll be helpful with domain and range to see those first. So let's start with vertical asymptote. There's a vertical asymptote. So this is letter C. At this point, I always highlight where those arrows seem to be getting close to. So that's at x equals 1. This is the exact same problem I just showed you. And our hole, so that's the vertical asymptote. Our hole, like I showed in the previous slide, this coordinate, you just name the coordinate, and if it's not right on something, use a decimal. So it looks like it's about -4, but then -1.2 or something. As long as it's close, you're good, because we're guesstimating. Then we're going to go ahead and do our horizontal or oblique. By the way, these are combined because you can only have one or the other, so there should only be one answer on this one, on letter D. It's either going to be horizontal or oblique. So this one's horizontal, which you don't have to write because it'll be obvious, because horizontal is always going to be like y equals some number, while an oblique asymptote is always going to be in the form y equals mx plus b. So this is y equals -1. Now I like to do that first because domain and range sometimes throws people off. So domain are all the x values if we're going from left to right. So if I go from left to right, what x values are we covering? Well, if you notice, there are actually only two places of discontinuity is what we call them. That is going to be where the hole is and where the vertical asymptote is. And that often happens. So it's everywhere but those places. So for the domain, you just say just x can't be -4 or +1. So notice those are from part C. Range, which I should have given myself more room. I'll do that right here. Range is kind of the same idea, but sometimes it's a little different, so you just got to be a little more careful on range. But range are all the y values, and you're just looking to see if there are any breaks in the graph and horizontally, and there's only one at the horizontal asymptote. Otherwise, you're always touching some point of the graph. So we would say y can't equal -1. Like I said, there are going to be times where that's not actually true, but domain should match up pretty much with letter C, just the opposite. Okay, intercepts, we're just naming x and y intercepts. So there looks like there's a y-intercept at 0, -3. and then a x-intercept at 3, 0. And that's it. Let's go to our next one. So over here, I'm going to write them down here. I'm going to space it out better so that I remember to leave some space. So, and then we've got C, and we'll put D right here. Okay. So let's go to vertical asymptote and holes first, because that always helps with domain. So right here is our vertical asymptote. So we're going to say it's at x equals 1 again. There are no holes. So when I go to domain, that means I'd say x can't be positive 1. So that was pretty easy. Now when it comes to range, to oblique asymptote, because that's what actually I'm going to do next. What you're going to do is just kind of roughly draw a line, and then where it looks like you're kind of getting there, to me it looks like it's about right here. So we're starting at -1. And it looks like if I just keep going up 1 over 1, and this is going to be a rough guesstimate as well, that looks to be about the asymptote. I'm getting really close. I'm going to say y equals, it's down 1, I should say, so -x minus 1, because that's my asymptote. So just doing it in the form y equals mx plus b. My slope is down 1 over 1, and my y-intercept is -1. Now, this is where range can be a little tricky, because it doesn't actually follow your asymptote half the time. So just notice that it looks like the graph goes from here and above, and then from here and below. So there's a massive gap in our graph right here. So there's nothing in this little range. So what I would do for range is I could do it as an interval. I don't care how you do this. So some people might do interval notation, -infinity to -4, and it looks like there's a point on -4. And then do a union 0 to infinity, something along those lines. Or you could do inequality, and I'll do that down here because we don't need a lot of room. So you could say y is less than or equal to -4, and y is greater than or equal to 0. So either way, that's fine. But let's go to letter B, intercept. So it looks like there's a coordinate at 0, 0, and that is it. I don't see any other x or y intercepts. So we're done with that problem.